Good morning. So as you go over your key, couple just reminders. So our positive ions are cations. Remember, cats are more beneficial in your house. Those are positive. Whereas anions, I always remember as ants. Ants are negative things. You don't want those in your house. So if it's a positive charged ion, it's positive because it has lost negative electrons. The number of protons now is greater than the number of electrons. Remember, the number of protons cannot change. So when we're looking at ions, ions are formed because electrons are either gained or lost. So in the second one, when they become negatively charged, that means the number of electrons now is greater than the number of protons. That ionic bond is going to form when a metal bonds to a nonmetal, or a cation bonds to an anion, or when one gains and one loses. The key is that electrons get transferred. So that cation loses electrons and those electrons go over to the nonmetal. So again, bonds between metals and nonmetals. Because they are oppositely charged, we know opposites attract. For number 6, remember that when we're looking at MgBr2, that Br2 is a subscript. The 2 indicates that there are 2 bromine atoms for every 1 atom of magnesium. So remember, that is a ratio of 1 magnesium to 2 bromines. Anytime you write the name, so that MgBr2 is magnesium bromide, remember the cation or the positively charged ion comes first. Okay? For 8 and 9, when we're trying to determine what is going to happen, we need to first look at the group that the element is in. So for example, oxygen is in group 16, which means it has 6 valence electrons. So it can either lose 6 or gain 2. Remember, the end-all goal is to reach that 8. So if it gains 2, it's going to be 2 additional electrons, 2 negatively charged particles, which is where we get that -2. Boron, being in group 13, has 3 valence electrons. It can either lose 3 or gain 5. Remember, it's always going to go with the lowest number. So it's going to lose 3. Right? So if it loses negative charge, if I tell you to lose a negative attitude, I'm asking you to become positive. For number 10, manganese 2 and phosphorus form an ionic bond. Because it gives you that Roman numeral, we know that manganese can have different charges. So that 2 indicates that it's going to be a +2. So we have Mn +2, P3-. You just crisscross, and your new chemical formula is Mn3P2, or manganese 2 phosphide. Remember, for our anion, we're going to drop the ending and add IDE, unless if it is a polyatomic. If it is a polyatomic, we will just write that name. So again, ionic form, when we have ionic bonds, one is going to gain, the other is going to lose electrons, and a goal to become stable. As you're looking at which of these statements refers to ionic bonds, remember, ionic bonds occur between a positive and a negatively charged ion, between a metal and a nonmetal, or a cation and an anion. Okay, one is going to gain, whereas one is going to lose. For rubidium and nitrogen, if we were to draw our Lewis dot diagrams, remember, we are adding Lewis dots only based upon the number of valence electrons. So rubidium is in group 1. It has 1 valence electron, so it's going to become a +1, +1, +1. Whereas nitrogen, being in group 15, 5 valence electrons, wants to gain 1, 2, 3, because it is missing 3 buddies. Once that happens, if you take a look, my charges do cancel out. I used 3 atoms of rubidium, so I'm going to write it as Rb3, and then I only have 1 atom of nitrogen, so Rb3n. So rubidium nitride. Remember, the anion, drop the ending, add IDE. On to the next page, same deal with my aluminum and oxygen. You might start to get good at this and be able to do your shortcut. So Al3 plus, O2 minus. I'm going to crisscross, and I get Al2, O3. So that's the shortcut method. However, in order to do the Lewis dot diagrams, we would still show our electrons leaving aluminum and going to oxygen. I still get 2 atoms of aluminum and I still get 3 atoms of oxygen. So that final formula is going to be the exact same, whether that I do it in the longer Lewis dot structure form, where I show the transferring of electrons with one-way arrows, or I can do it in my shortcut method with the crisscross method. My final chemical name, aluminum oxide. Remember, the cation name stays the same. The anion name, drop the ending and add IDE. When you go down into your chart, a couple things to remember. Hopefully you have above each of your groups identified what charge each group will form. So sodium is going to be a +1, sulfur is going to be a 2-, and then you will just crisscross. Remember, sodium does not become a -2 charge. It just means that I have 2 atoms of sodium, each with a +1. So it's really Na +1, Na +1, S2- is going to cancel out. In order to name it, again, cation first, don't do anything to that name. Anion second, drop the ending and add IDE. The only time that we are going to need a Roman numeral is with something like nickel 3 nitride. That 3 indicates that it has a +3 charge, and that's because it is a transition metal. So I don't do anything different other than adding that Roman numeral. If it is a polyatomic like PO4 3- or NO2 1-, when I add the name at the end, it's just going to be nitrite or nitrate or phosphate or carbonate. So I don't have to do anything to that name. I just need to go up into my chart, grab it, crisscross, and then go ahead and solve for my ionic compound. For number 17, when we are looking at which is likely to form the ionic compound, remember argon is a noble gas, so that is never going to form an ionic compound. So the very last answer choice, argon chloride, is a noble gas, not going to happen. Sulfur dichloride, we haven't done anything with prefixes like mono, di, tri, anything like that, so we know that's not correct. Not only that, it's sulfur and chloride, which are 2 nonmetals. Definitely not right. And then our options between magnesium chlorine and beryllium chloride, if it's an ionic compound, remember it ends with IDE. So since that magnesium chlorine says chlorine and not chloride, can't be that one. For number 18, sorry, our subscripts got superscript, so those should be subscripts. Same exact deal as you're looking through. You want to make sure that you have a metal and a non-metal bonded together. No nonmetals bonding to nonmetals, no 2 metals bonding to each other, and no noble gases. So you can see which ones I X'd out, and I gave you a little explanation for it as well. For 19, neon, again, is a noble gas, so it's not going to form an ion, and it has no ionic charge. For 20, remember, the one thing we wanted you to know for polyatomic ions is that it is multiple atoms that are bonded together through covalent bonds. They are non-metals, remember, like NO3. Nitrogen is a non-metal, oxygen is a non-metal. Those are held together because they are sharing electrons. Remember, nitrogen and oxygen both want to be negative. So what happens when both you and your siblings want something? Mom's going to make you share it. So they actually share their electrons. So that is a covalent bond that holds it together. But then since it does have that ionic charge, it has a -1, it could form an ionic bond with, say, maybe calcium. And then you would do everything the same, criss and cross. Okay? All right, please let us know if you have any questions. Good luck tomorrow on your quiz.